Hello everyone, today we are going to see about example 2.1. Consider the second order equation, that is t square x double dot plus t x dot minus x equal to 0. So it is the observation given here is y equal to x dot. Uh, Instead of second order equation, we have to compute into the first order equations, make some assumptions. So to convert the second order equation into first order, we assume that x1 equal to x, x2 equal to x dot. So here x1 dot is nothing but if we take the derivative, dot represent the derivative, x1 dot equal to x dot equal to x2 and x2 dot equal to x double dot. So first equation, t square x double dot plus t x dot minus x equal to 0, t square x double dot plus t x dot equal to x, t square x double dot equal to x minus t x dot. So x double dot equal to x divided by t square minus t x dot divided by t square, t getting cancelled, x dot equal to x divided by t square minus x dot divided by t. Okay, then x can be replaced as x1, so x1 divided by t square minus x dot can be replaced by x2 divided by t. So it is in the written in the form of x dot t a of t x of t. So x dot of t is x1 dot x2 dot, that is here is 0 and 1, so 0 1, 1 by t square minus 1 by t x1 x2. So x dot of t equal to a of t into x of t, h equal to 0 1, 1 by t square minus 1 by t. So by the property we know that x of t comma s is nothing but x of t into x inverse of s. So for that we assume that x of t comma 1 is, we take x of t comma 1. So x of t x inverse of 1, we have to find the x of t and then x inverse of 1. So x of t is nothing but first we take t square x double dot plus t dot x t x dot minus x equal to 0, and then t square x double dot is nothing but x2, t square x2 which is nothing but x double dot can be represented as x2 dot and plus t x dot is represented as x1 dot minus x1 equal to 0. So we take x1 equal to t power r, x1 dot equal to derivative of the term r into t power r minus 1. So x double dot is nothing but one more time derivative r into r minus 1 t r power minus 2. So we know that tx2 plus tx1 dot minus x1 equal to 0, or otherwise we can replace that r into r minus 1. Instead of, we replace this as x1 double dot. How means in x can be replaced by x1, so instead of x we can replace x1 double dot. So x1 is assumed as t power r, x1 dot is r into t power r minus 1, x1 double dot is r into r minus 1 t power r minus 2. So t square, take the derivative means r into r minus 1 t power r minus 2 plus t into r into t power r minus 1 minus t power r. So if we derivative means r into r minus 1 t power r plus r into t power r minus t equal to 0. Take t power r as common means r into r minus 1 plus r minus 1 equal to 0, and r into r minus 1 plus r minus 1 equal to 0, and this form is r equal to 0. We get the terms as r plus 1 r minus 1, so r will be plus or minus 1. So consider r equal to 1, r equal to minus 1 means substitute that in x1. We have to find the x1 and x2 value. If we substitute r equal to 1 means it will be x1 will be t and minus 1 is t power minus 1. So then x1 of t is t means x2 is nothing but the derivative of the x1. So x1 dot is nothing but derivative means 1. So x1 equal to t inverse, x2 equal to what is that, x2 is nothing but x1 dot, so it is minus 1 by t square. So our x of t can be written as x1 into x1 x1 term into x2 terms in a um, in a column wise. So t 1 and 1 by t minus 1 by t square. Okay, then instead of t we can replace 1, means we get our x of 1 value. So 1 1 1 minus 1. So x inverse of 1, we have to find the x inverse of 1. X inverse of 1 is 1 by determinant of x of 1 into adjoint of x of 1. That is, we take the determinant minus 1, that is minus 1 2, that is minus 1 by 2. Adjoint of is replace the first and fourth, so minus 1 by 1, put the minus on b and c, so minus 1 and minus 1. So if we multiply minus 1 by 2, means we get 1 by 2 1 by 2 1 by 2 minus 1 by 2. We have to find x of t comma 1 for the fundamental matrix of the term. So it will be x of s can be s comma t can be written as x of s x inverse of t. So instead of x of t comma 1 can be written as x of t into x inverse of 1. Okay, so x of t, we know that t 1 by t 1 minus 1 by t square. X inverse is nothing but 1 by 2 1 by 2 1 by 2 minus 1 by 2. So 1 by 2, take 1 by 2 as common, means t 1 by t 1 minus 1 by t square 1 minus 1. So 1 by 2 is, if we multiply, means t plus 1 by t and t minus 1 by t, t minus 1 by t square and 1 1 plus 1 by t square. So that's it. So now the observation we have to the observation is y equal to x dot is nothing but x2. So it will be 0 1 x1 x2. If we multiply, means we usually get x2 terms. So h of y is nothing but h of t into x of t. Our x of t is nothing but x of t comma 1. Okay, so 1 by 2 into 1 by 2 into 0 1 t plus 1 by t 1 t minus 1 by t 1 minus 1 by t square 1 plus 1 by t. So 1 by 2 into this terms 1 minus 1 by t square and 1 plus 1 by t square. So taking s equal to 1 s equal to 2 means h of s1 x of s1 comma 1 h of 1 x of 1 comma 1. So we replace all the terms as 1. So 1 by 2 into, instead of t replace 1, means we get 0 comma 2 and divide means 0 comma 1. H of s2 comma 1 is h of 2 x of 2 comma 1. So 1 by 2 1 minus 1 by 4, which is, instead of t we replace 2 square is 1 by 4, 1 plus 1 by 4, it is 1 by 2 and 3 by 4 5 by 4. If we multiply 1 by 2, it means we get 3 by 8 5 by 8. So our rank is h1 of x of, while we are finding this terms, means our rank will be h1 into x of, because we are having a 2 matrix. So h of 1 x of 1 comma 1 h of 2 x of 2 comma 2. For that purpose we are using s1 equal to 1 and s2 equal to 2, and instead of, then we are finding h of 1 term and h of 2 terms, all of this, because with the having the rank term h1 we have to find the h1 into x of 1 comma 1 h2 into x of 2 comma 2. So for that rank will be this is 0 1 and this is 3 by 8 5 by 8. If we means we get minus, it's nothing but minus 3 by 8, that is not equal to 0, and otherwise the rank is no rank, there is no 0 term, it is 2. So it is, the system is observable. Hope you all understand, and thank you.